Hello everyone, welcome to Time Online Classes. Today in this session we will discuss number series basics. So please be kindly ready with your notebook and pen. In this class we will discuss number series basics, and in the another session we will discuss number series exercise questions. Okay. What is a series? A sequence of numbers or letters which follow a certain rule is called a series. You will be given a sequence of numbers or letters and there will be having a particular rule, whether we call it as a series. A series may be of number series, a series may be of a letter series. Now in this session we will discuss number series basics and we will be having one more session on letter series basics also. Okay, so for today we will go with number series basics. Classification of numbers for number series topic, a very important concept in the number series. Classification of numbers for number series topic. Natural numbers. What are natural numbers? Countable numbers. Starts from 1, 2, 3, 4, 5 and so on. All these numbers comes under the natural numbers, countable numbers. And next, even numbers. Which numbers we call them as even numbers? The numbers which are exactly divisible by 2, we call them as even numbers. And which numbers we call as odd numbers? The numbers which are not exactly divisible by 2, we call them as odd numbers. So odd natural numbers 1, 3, 5, 7, 9 and so on. So these numbers are not divisible by 2. So odd numbers. And even natural numbers. Even natural numbers. The numbers which are exactly divisible by 2, we call them as even numbers 2, 4, 6, 8, 10 and so on. Or every alternate number starting from 2. Odd numbers, every alternate number starting from 3. So natural numbers, odd numbers, even numbers. So the next point which we are going to discuss is a very important for the number series topic. That is prime numbers. Which numbers we call them as a prime numbers? The numbers which are divisible by 1 and itself, we call them as prime numbers. Or the numbers which are having only 2 factors, we call them as prime numbers. Those only 2 factors are 1 and itself. Okay, let's say an example 2. 2 is divisible by 1 and 2 is divisible by 2. 1 and itself. Let's take 3. 3 is divisible by 1 and 3 is divisible by 3. So 1 and itself. Now let's take 7. 7 is divisible by 1 and 7 is divisible by 7. 1 and itself. Let us take an example 6. 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by 6. So it is not. This is not a prime number because it is divisible by more than 2 numbers. It is having more than 2 factors. So the numbers which are having exactly 2 factors, we call them as a prime numbers. Or the numbers which are divisible by 1 and itself, we call them as prime numbers. And prime number starts from 2. 2, 3, 5, 7, 11 and so on. And the prime numbers does not follow any specific pattern. So better you have to by heart these prime numbers. Clear? Now move ahead. Composite numbers. Which numbers we call them as a composite numbers? The numbers which are having more than 2 factors, the numbers which are having more than 2 factors, we call them as composite numbers. Let's say 6. 6 is having more than 2 factors. 8. Divisible by 1, divisible by 2, divisible by 4 and divisible by 8. So 8 is also having more than 2 factors. So these numbers we call them as composite numbers. Or we can also say the numbers which are not prime, we can call it as composite numbers. We can call them as composite numbers, but there will be an exception. 1 is neither a prime nor composite. 1 is neither a prime nor composite. All the numbers which are not prime, you can say it as composite numbers, except 1. 1 is neither a prime nor composite. Clear? No. Non-prime numbers. So the numbers which are not prime, the numbers which are not prime, we call them as non-prime numbers. So 1 is missing, 2, 3, 4 is missing, 5, 6 is missing, 7, 8, 9 missing, all these numbers, 8, 9, 10, all these numbers we call them as non-prime numbers. Here 1 also will come because 1 is not a prime. So we are taking non-prime numbers. So classification of numbers, very, 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 very important, because if we solve any number of questions, that has to fall under the following categories: natural, odd numbers, even numbers, prime numbers, composite numbers, non-prime numbers. You need to understand the sequence. Fine. Please note it down. Completed? Okay. So let's see the rules followed in a number series. Directions for questions 1 to 20. Find the missing number in the given series. So we need to identify the missing number in the given series. Now, what is the given series? 56, 57, 58, blank, 60, 61, 62. So here we need to identify that what will come in the place of blank. Okay. Now, 56, 57, 58, 60, 61, 62. If you observe that 56 to 57, it is increased by 1. 57 to 58, it is increased by 1. 60 to 61, it is increased by 1. 61 to 62 also increased by 1. So here also what we can say that increased by 1, and from the blank to the next number also it has to follow the same logic. So 58 plus 1, 59. So answering this question is very, very easy. But here the important thing is classification of numbers. So instead of thinking in this way, plus 1, plus 1, plus 1, plus 1, plus 1, what I suggest you is identify the classification of numbers. 56, 57, 58, 59, 60, 61, 62 comes under the consecutive natural numbers, because here we are discussing the rules that are followed in the number series. So one of the rules that will be followed in the number series is consecutive series. Consecutive series. The first one. The first rule that followed in the number series is consecutive series. See, dear students, how can we understand that the given series is of a consecutive series? It is very, very important for us. So how to identify the given series as a consecutive series means numbers themselves follows a specific pattern. Numbers within themselves follows a specific pattern. The patterns are just now we discussed that natural numbers, even numbers, odd numbers, prime numbers, composite numbers, non-prime numbers, alternate even numbers, alternate odd numbers, alternate prime numbers, alternate composite numbers, alternate non-prime numbers. So these consecutive series may come under that category. All those logics will come under the category of consecutive series. Numbers themselves follows a specific pattern. So here the number themselves following the pattern of what? Consecutive natural numbers. So what is after 58 natural number is 59, and after 59 60. It is perfectly matching. So what is your missing number? 59. So that is choice 4. Choice 4 is our answer. Clear? And this comes under the category of consecutive series. Consecutive series. Numbers themselves follows a specific pattern. Okay. And please keep noting it down parallelly. Okay. You have to write, you have to listen, and you have to understand the logic. Clear? Let's see the question number 2. 41, 43, 47, 59, 61. What are these numbers? 41, 43, 47, 59, 61. Let's check it that number themselves following any specific pattern. And we have discussed earlier, when the prime number series is given, that won't follow any specific pattern. So we have to remember the prime numbers. So what are the prime numbers that we have to remember? Means between 1 to 100, the numbers, prime numbers which we have, that we need to by heart them. Okay. What are the prime numbers that we have between 1 and 10? 2, 3, 5, 7. Between 11 and 20, 11, 13, 17, 19. 20 and 30, 23, 29. 30 and 40, 31, 37. 40 and 50, 41, 43, 47. 50 and 60, 53, 59. 60 and 70, 61, 67. 70 and 80, 71, 73, 79. 80, 90, 83, 89. Between 91 to 100, 97. So these are the 25 prime numbers that we have between 1 to 100. So please try to remember these numbers. Please try to by heart them. Okay. 2, 3, 5, 7 between 1 and 10. 11, 13, 17, 19 between 10 and 20. 20 between 20 and 30, 23, 29. Between 30 and 40, 31, 37. Between 40 and 50, 41, 43, 47. Between 50 and 60, 53, 59 and so on. So please try to by heart these prime numbers. Okay, and note it down. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. So in number series topic, not only in number series topic, we have analogies and we have odd bin out. Everywhere these prime numbers plays a main role. Okay, so better to by heart these numbers. Now look at here. 41, 43, 47, blank, 59, 61. If you are aware of these prime numbers, 41, 43, 47, what is next? Blank, 59, 61. So what is the missing number will be definitely 53. So when we are thorough with the prime numbers, easily you can recognize the missing number and easily you can understand the pattern. So what is this logic is? Consecutive prime numbers. It comes under the category of consecutive series. Numbers themselves are following a particular pattern. What is the pattern? Prime numbers. So consecutive prime numbers. Consecutive prime numbers. Fine. So what is the missing number in the series? 53. It is in which option? Choice 3. Choice 3. Clear? Look at this. 1, 4, 9, 16, 25, blank and 49. What are these numbers? Again, are the number themselves following any specific pattern? Yes, these numbers are following a specific pattern. What is that pattern is? Squares. Squares. So how can we understand the given numbers are squares if we know these numbers as a squares? So let us discuss what are the squares that we have from 1 to 30. Okay. And please try to by heart the squares. So if you are thorough with the squares numbers, by looking at the given series, you can understand that the given numbers are squares or not. If you can understand the given numbers as the squares, then you can apply the logic of squares. It is quite simple. But you have to understand the given numbers. You have to recognize the given numbers as a squares. For that, you need to by heart those numbers. Okay. So here is a list of squares up to 30. Please note it down or take a screenshot of this. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100, 11 square 121, 12 square 144, 13 square 169, 14 square 196, 15 square 225 and so on up to 30 squares. Up to 30 square. So please try to by heart these numbers from 1 to 30 squares. Per square up to 30. please try to by heart these numbers. If you can by heart these numbers, answering this kind of questions will be very easy. Okay. Now look at these numbers. 1 is 1 square, 4 is 2 square, 9 is 3 square, 16 is 4 square, and 25 is 5 square, and the 49 is 7 square. Now look at here. Clearly it is visible that the given logic is of squares. It is 1 square, 2 square, 3 square, 4 square, 5 square, and missing blank and 7 square. So what will come in the place of blank? That is very important. Okay. So anyway, the given logic is square, but which number squares is also very important. That. So here again, that main important point is classification of numbers. Look at here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 are given consecutively. So what this comes under? Consecutive natural numbers. So after 5 will be 6, and the logic applied is squares. So the classification of numbers are consecutive natural numbers, and the logic applied is squares. 6 square is 36. So what is my required answer? 36. Choice 1. And the logic is squares of consecutive natural numbers. Squares of consecutive natural numbers. So here the ultimate thing is we have to recognize the given numbers as the squares, and after that you have to cross check that which number squares those numbers are. Whether they are natural number squares or even number squares or odd number squares or prime number squares or composite number squares, that you need to cross check with the classification of numbers. Then you can find out the exact answer. Clear? So what is the logic is? Squares of consecutive natural numbers. Choice 1. Squares of consecutive natural numbers. So far, I told you to by heart the two important points. One is prime numbers, 1 to 100. We have total 25 prime numbers, and then squares up to 30. Now go to the next question, number 4. No, 144, 100, 64, 36, 16. And remember that you have by hearted the squares and you are thorough with the square numbers. Then identify the logic here. 144 is 12 square, 100 is 10 square. This is the advantage that we have if we by heart the prime number, squares or the prime numbers. So if you are thorough with the prime numbers, by looking at the given series, you can say that these numbers are perfect squares. And 64 is 8 square, 36 is 6 square, and 16 is 4 square. Look at here, 4 square, 6 square, 8 square. If we feel it is even number, so next should be 10, and then should be 12, and then should be 14. But here 12 and 10 are given. Now we need to identify the missing number. Here we need to identify the missing number. Okay, the numbers are squares. There is no doubt in that. The given numbers are perfect squares. So here also we need to identify the perfect square, but we need to identify which number perfect square. Now identify the pattern. It is definitely not the even number squares. 4 and 6, which is missing? 5. And okay, 6 and 8, which is missing? 7. Okay, 10 and 12, which is missing? 11. Now look at here, 5 is missing, 7 is missing, 11 is missing. It means prime numbers are missing. Which are missing? Prime numbers are missing. So what I can consider here? So prime numbers are missing, which is nothing but we are taking composite number squares. So after 9, what is a composite number? 9. So 9 square will be 81. Clear? So what is my logic is? Consecutive composite number squares in decreasing order. So the given series may be of increasing order or the given series may be of decreasing order. They may give in any pattern. So the first 3 examples are of increasing order. Now here is the example is of decreasing order. So it can be of increasing order. It can be of decreasing order also. Okay. Now here the logic is consecutive composite number squares in decreasing order. So first we have checked with the even number squares, but it is not matching. 4, 6, 8, 10, 12 consecutively, but we need to identify the one more missing between 8 and 10. And 4 to 6, 5 is missing, 6 to 8, 7 is missing, 10 to 12, 11 is missing. So prime numbers are missing is nothing but non-prime number squares or composite number squares. Clear? So what is the missing number? 81. So choice 1. And the logic is consecutive, squares of consecutive, not even numbers. Please make a correction. It is composite numbers. Composite numbers in decreasing order. Squares of consecutive composite numbers in decreasing order. 12, 10, 9, 8, 6, 4. Fine. So choice 1. Squares of consecutive composite numbers. Okay. Look at the given numbers. 8, 64, 216, 512. Now observe the numbers. Are the numbers themselves following any specific pattern? It means yes. But we have to know what are these numbers. These numbers are perfect cubes. These numbers are perfect cubes. So we should be thorough with the cube numbers up to 15. So please by heart these cubes up to 15. Please make a note of this. 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, 6 cube 216, 7 cube 343, 8 cube 512, 9 cube 729, 10 cube 1000, 11 cube 1331, 12 cube 1728, 13 cube 2197, 14 cube 2744, 15 cube 3375. So please by heart up perfect cubes up to 15. Now, so once by looking at the given series, if you can recognize the given numbers as a cubes, then answering the question will be very easy. So 8 is 2 cube, 64 is 4 cube, 216 is 6 cube, and 512 is 8 cube. Now, cube, 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 cube. So the logic is of cube. There is no issue in that. But which number cubes these numbers are? 2, 4, 6, 8. Again, the main important point is classification of numbers. 2, 4, 6, 8 comes under which classification? Consecutive even numbers. 2, after that 4, again 6, and again 8. Consecutive even numbers. So after 8 even number is 10. And the logic applied is cube. So 10 cube. 10 cube is how much? 1000. So what is my answer is 1000. And what is the logic given here? Consecutive even number cubes. Cubes of consecutive even numbers. So here the ultimate and the important thing is you need to recognize the given numbers as a cubes. After recognizing the given numbers as a cubes, you need to check for the classification of numbers. Natural, even, odd, prime, composite, non-prime, alternate even, alternate odd, alternate prime, alternate composite. All these classification of numbers you need to cross check. Then you can find out the exact answer. Right? No. So 10 cube is 1000. Cubes of consecutive even numbers. And the logic is choice 4. And please keep noting down parallelly. I won't be telling you again. Note this, note that. Every point you have to note down. You need to note down the question and the choices, logic also. Or take a screenshot of this. No issue. Okay. Move to the next one. 127, 125, 729. Okay. Now look at here. Try to recognize these numbers. 1 is 1 cube. 27 is 3 cube. 125 is 5 cube. 729 is 9 cube. Just now we discussed 1, 3, 5, 9. And the numbers are of cubes. 1 cube, 3 cube, 5 cube, and blank 9 cube. So what are these numbers classification? 1, 3, 5 missing and 9. So 1, 3, 5 blank 9. What is the missing number will be? 7. Because 1 next odd number is 3, 3 next number odd number is 5, next odd number is 7, 7 next odd number is 9. So consecutive odd numbers. And the logic applied is cube. So what is the missing number? 7 cube, which is 343. So you have to be a bit careful with prime numbers and odd numbers. Look at here. 2, 3, 5, 7, 11. This is of prime numbers. 1, 3, 5, 7, 9 is odd number. Alternate numbers will get here. But in this case, we won't get alternate numbers every time. Okay. So 2, 3, 5, 7, 11 is prime number series. And 1, 3, 5, 7, 9 is odd number series. Please be careful. Okay. While you are choosing. So 1 cube, 3 cube, 5 cube, 7 cube, 9 cube. 7 cube is 343. So choice 2. So what is the logic given here? Cubes of consecutive odd numbers. So here also what we are doing, we are identifying the given numbers as a cubes. Then we are checking that classification of numbers. Quite simple, right? So all these 6 examples, whatever we have discussed, comes under the category of consecutive series. So how can we understand the given series is of consecutive series? It is very simple. Numbers themselves follows a specific pattern like prime, even, odd, composite, non-prime, perfect squares, squares of natural, squares of even, squares of odd, squares of composite, perfect cubes, squares of consecutive natural, cubes of consecutive natural numbers, cubes of consecutive even, cubes of consecutive odd. All these logics comes under the category of consecutive series. And what are the 3 points that are important and that we need to by heart? Prime numbers, squares and cubes. Okay. Now move to the next logic. 120, 125, 131, 138, 146. Now it is the second rule. But even before going to the second rule, how can we understand that it is of not a consecutive series? It is quite and crystal clear. Are the number themselves following any specific pattern or not? We need to observe. 120 is even, 125 is odd. And there are no prime numbers. And these numbers are not a square, these numbers are not a cubes. So then we can say that these are not following a consecutive series. Numbers themselves not following any specific pattern. If it is not, you need to observe the 2 points. Are the given numbers are in increasing pattern, increasing series, or decreasing series? Increasing series or decreasing series? Now is it increasing or decreasing? Increasing. Now when it is increasing or decreasing, again in this we need to observe the 2 points. Whether it is increasing gradually or whether it is increasing rapidly, that we need to observe. Okay. Gradually means there will be a small jump from one number to the another number. There will be a small jump from one number to the another number. Rapidly means there will be a big jump from one number to the another number, like 2 times, 3 times, 4 times multiplication. So that we can say that increasing rapidly. If it is increasing gradually, we will apply the logic of difference. If it is increasing rapidly, we will apply product logic. Okay, we will apply product logic. Increasing gradually, difference logic. Increasing rapidly, product logic. Okay. Whether increasing or decreasing gradually, we will go with the difference logic. But if it is decreasing rapidly, we will go with the divisibility. Divide by logic. Increasing or decreasing gradually, difference only. But increasing or decreasing, increasing rapidly, product, decreasing rapidly, divisibility logic. Okay. Now look at this question and tell me. Given series is an increasing series, okay. Is it increasing gradually or rapidly? Increasing gradually. There is a small jump from one number to the another number. So increasing gradually, we need to apply the difference logic. Now once check the difference. 120 and 125, difference is 5. 125 and 131 increased by 6. 131 and 138 increased by 7. 138 and 146 increased by 8. Now look at these numbers. 5, 6, 7, 8. See, we are able to say that the logic is different, but the difference is of which numbers? Again, the classification of numbers. 5, 6, 7, 8. Where we will get consecutively these numbers 5, 6, 7, 8 in natural numbers. So after 8, natural number is 9. So 146 plus 9, which is 155. So what is the required answer is 155. Choice 3. So ultimately the given logic is difference logic, but difference of which numbers? Consecutive natural numbers. So difference is the consecutive natural numbers. Again the same classification, but the important and the ultimate thing is you need to recognize the given logic is of difference. Then again in that one you may apply the classification logic, even, odd, prime, composite, or squares of even, squares of odd, squares of prime. All this you can apply. Okay. So what is the logic comes under? Difference logic. What is the difference? Difference of consecutive natural numbers. So choice 3. Difference is, I am writing in a short form, please note it down. Difference is consecutive natural numbers. Consecutive natural numbers. Okay. Now move to the next example. 129, 148, 171, 200, 231. But the numbers are increasing gradually or rapidly. One number to the another number, there is a small jump or a big jump? Yes, small jump. Because numbers are close to each other. Numbers are close to each other. So increasing gradually. Increasing gradually, which logic we are going to apply? Difference logic. So once check for the difference. 129, 148, how much is the difference? Plus 19. You should be thorough with bit calculations. 148 and 171 difference is how much? 23 plus 23. 171 and 200 difference is how much? Plus 29. 200 and 231 difference is how much? 31 plus 31. Now look at these numbers. 19, 23, 29, 31. What are these numbers? What are these numbers? 19, 23, 29, 31 are consecutive prime numbers. Consecutive prime numbers. Consecutive prime numbers. So after 31, what is the prime number will be? 37. So 231 plus 31 will be how much? 268. So what is the required answer? 268. So what is the logic is here? Difference is consecutive prime numbers. In the earlier case, what is the difference is? Consecutive natural numbers. Now here the difference is consecutive prime numbers. Okay. The ultimate thing is we have observed the given logic as we recognize the given logic is difference, and then we are checking that the difference is of which numbers. Now here the difference is of consecutive prime numbers. Clear? So difference is consecutive prime numbers. So choice 1 is our answer, 268. Example number 9. Now look at here. The numbers are in increasing pattern or decreasing pattern? Decreasing pattern. Decreasing slowly or rapidly? I mean gradually or rapidly? There is numbers are close to each other, right? 107, 99, 91, 83. We can observe that. Numbers are close to each other. So when the numbers are close to each other, we can say that these are decreasing gradually. Decreasing gradually. Whether it is increasing gradually or decreasing gradually, we will check for difference logic only. Right. Now see here how much is the difference. 107, 99 minus 8. 99, 91 minus 8. 91, 83 minus 8. Now observe here, in earlier two examples, it is following some classification like consecutive, natural, consecutive. But here everywhere the given number is subtracted by 8. Now again I need to apply the same logic. 83 minus 8. What is 83 minus 8? 75. Now 75 minus 8, 67. Perfectly matching. So what is the missing number in the series is 75. Choice 2. So here it is decreased by a constant number. Decreased by constant number. Decreased by a constant. What is that constant here? 8. Okay. So it can be anything. It can be a 10, it can be 12, it can be 13. They may give any number. Decreased by a some constant. So choice 2. And the logic is minus 8, minus 8, minus 8, minus 8, minus 8. So decreased by some constant, that is 8. Unlike earlier, there it is followed a specific pattern like consecutive prime numbers, consecutive natural, but here it is not. It is decreased by some constant number. Okay. Now move to the next example. Now, 37, 60, 48, 71, 59, 82 blank. Now see here. Here to here it is increasing, but here to here it is decreasing. Again increasing, decreasing. Again increasing. Look at here. Increasing, decreasing, increasing, decreasing, increasing. So what should be next? Decreasing. Because increasing, decreasing, increasing, decreasing alternately applied. And are the numbers are close to each other? Yes, absolutely. 37 to 60 numbers are close to each other. 60, 48 also close to each other. So increasing gradually and decreasing gradually. But in any case, what is the logic that we are going to apply? A difference. So apply the difference logic. So 37, 60, how much is increased by? Plus 23. 60 and 48, how much it is reduced by? Minus 12. 48 and 71, plus 23 again, okay. 71, 59, minus 12. 15 and 82, plus 23. So here also it is not following any classification, but here we have taken two constant numbers. One is 23 and one more is 12. So 23 is increased, 12 is decreased alternately. So what should be next? Minus 12. So 82 minus 12 will be how much? 70. So what is the required answer? 70. So here we have taken two constant numbers, that is 23 and 12. In the earlier case we have taken minus 8. But here it is increasing and decreasing. So wherever it is increasing, increased by 23. Wherever it is decreasing, decreased by 12. Clear? So choice 1. Look at these numbers. 116, 125, 141, 166. Are the numbers are close to each other? Yes. Because I cannot see any rapid jump, very big jump from one number to another number. But if I observe the difference, 116 and 125, how much is the difference? Plus 9. Numbers are in increasing pattern and increasing gradually. If it is increasing gradually, we'll check for difference logic, right? So check for the difference logic. 116, 125 plus 9. 125, 141 plus 16. Can you able to recognize these numbers? 9, 16. Yes, very good. 9 is 3 square. 16 is 4 square. Now 144, 166 increased by 25. So 25 is 5 square. So difference is squares. But which number squares? Once observe the classification. 3, 4, 5. Where you get 3, 4, 5 consecutively, we get in natural numbers. So after 5 natural number is 6. 6 square is 36. So what is my answer should be? 166 plus 36. So 166 plus 36 is equal to how much? 202. So choice 4 is my answer. Choice 4. So what is the logic here is? Difference is consecutive natural number squares. Natural number squares. Natural number squares. Now if you observe one important point here. First we have discussed the consecutive series logic. And now we have discussed the difference logic. But when you are observing the difference logic, again all we have got the logics which we have discussed in the consecutive series. Difference as a consecutive prime numbers, difference is a consecutive natural numbers, difference is a consecutive natural number squares, difference may be the consecutive natural number cubes. So whatever all the logics that we discussed during the consecutive series pattern, that all can be converted into the difference, but it is in the pattern of difference. Clear? Now move to the next example. Now look at this. 1, 1, 2, 6, 24, 120. Are the numbers are increasing rapidly or increasing slowly? or one number to the another number is a small jump or a big jump. 24, 120, there is a big jump. 6 and 24, there is a big jump. Generally, we will observe last three numbers. Last three numbers. That is enough. When it is in increasing pattern. When the numbers are in increasing pattern, observe the last three numbers. Okay. In 99% cases, you will get this as a correct. Okay. Whatever we are going to apply. If it is a decreasing pattern, first three numbers. To confirm that whether it is decreasing rapidly or decreasing slowly, increasing rapidly or increasing slowly. So 624, there is a big jump, almost 4 times. 24, 120, 5 times. So, or another way of saying is, when can you say that the given series is increasing rapidly? Numbers are multiples of each other. 120 is a multiple of 24. 24 is the exact multiple of 6. In these cases also you can say that increasing rapidly. Okay. One number is a multiple of the other number. So 24 and 125. How many times you can multiply? 5 times. It goes exactly 5 times. 624 it goes exactly 4 times. 2, 6 it goes exactly 3 times. 1 and 2 it goes exactly 2 times. 1 and 1 it goes exactly 1 time. So 1 time, 2 times, 3 times, 4 times, 5 times. What are these numbers? The numbers which you are multiplying are 1, 2, 3, 4, 5 consecutive natural numbers. Next to 5 natural number is 6. So 120 into 6, 720. So my answer will be 720. Choice 1. And what is the logic is? Product of consecutive natural numbers. Product of consecutive natural numbers. So whatever all we have discussed during the consecutive pattern, all can be given in the form of product also. Clear? So the logic is product logic. So it is our third logic. So we have done with the consecutive series, we done with the difference series. Now we are discussing the product logic. Okay. How can we understand that? The given numbers are multiples of each other, or there is a big jump from one number to the another number, and focus on the last three numbers or the first three numbers. Okay. Decreasing order, first three numbers. Increasing order, last three numbers. Okay. So choice 1. Question number 30. Look at here. 10, 20, 60, 300, 2100. So there is a big jump. Again here is also big jump. So what I can say that? Increasing rapidly. If it is increasing rapidly, what is the logic that we are going to apply? Product logic. And don't be fear of calculations. You are able to identify that the logic as a product. So then just do the multiple calculations and identify the answer. 300 and 2100, it goes exactly 7 times. 307. 60, 300, it goes exactly 5 times. 20, 60, it exactly goes 3 times. 20, it goes exactly 2 times. Look at here. 2 times, 3 times, 5 times, 7 times. What will be next? 2, 3, 5, 7. What is this classification? Consecutive prime numbers we discussed. 2, 3, 5, 7. Consecutive prime numbers. So after 7 will be 11. So 2100 into 11. How to calculate it? 2100 into 10 times is 21,000. It is easy. And one more time is 2100. Totally 23100. 23100, choice 2. And what is the logic is? Product of consecutive prime numbers. Consecutive prime numbers. Product of consecutive prime numbers. So choice 2 is our answer. Clear? So ultimate thing is we need to observe the given logic as a product and then apply the classification. Then check that the given numbers which we are multiplying comes under which classification. So 2, 3, 5, 7 prime number classification. So after 7, 11 is a prime number. Fine. Look at here. 4, 5, 12, 39, 160. Okay. 4, 5, 12, 39, 160. Here to here. Is it a small jump or a big jump? Very big jump. 12, 39. Yes, it is also big jump. But is it exact multiple? Is the 160 goes exactly in 39? 39 fourths maximum. But 39 fourths is 156. But what is the given number? 160. Is it good exactly? No, it is not exact multiple. But it is increasing rapidly. Increasing rapidly, no doubt, but not exact multiple. Then we can go ahead with the combination of difference and product together, or alternately difference and product together we can apply. Okay, so this logic comes under product and difference logic together. When we have to apply increasing rapidly but it is not an exact multiple, then you can apply this combination, difference and product combination. So 39 fours are 156, but it is how much more than that by 4? So plus 4 into 4 plus 4. 12 and 36, it goes maximum 3 times. 12 3 is 36 plus 3. 5 and 12 into 2 plus 2. 5 2 is 10 plus 2. 4 and 5, 4 1s are 4 plus 1. So into 1 plus 1, into 2 plus 2, into 3 plus 3, into 4 plus 4. Now look at that. The numbers which we are doing the product 1, 2, 3, 4. What is the classification? 1, 2, 3, 4 consecutively comes under consecutive natural numbers. So after 4 natural number is 5. So multiplied by 5. And also we need to identify the numbers which we need to add. Plus 1, plus 2, plus 3, plus 4. 1, 2, 3, 4 comes consecutively in natural numbers. So after 4 again will be 5. So what is my answer? Into 5 plus 5. So 160 into 5 is 800 plus 5 is 805. So choice 3, 805. And what is the logic is? Difference and product. What is the logic applied? Into 1 plus 1, into 2 plus 2, into 3 plus 3, into 4 plus 4, into 5 plus 5. So required answer is 805. So choice 3 is our answer. Clear? And it comes under the category of product and difference logic. Product and difference logic. Now, look at the question number 15. 4, 11, 25, 53, 109. Is it increasing rapidly? Yes. It is almost twice, right? 25, 53, yes, twice. Nearer to. 11, 25 is also nearer to twice. It is nearer to twice or thrice. Okay, let's see. 53 and 109. Maximum it goes how many times? 2 times. But it is not exact multiple. 53 to 106. So how much it is more than that by 3? So into 2 plus 3. Now look at 25 and 53. Maximum it goes to for 2 times. 25 to 50. But what is the given number? 53. So into 2 plus 3. 11 and 25, look at here. 11 to 22 plus 3 is 25. Perfectly matching. So what is the logic that you can confirmly say? Into 2 plus 3, into 2 plus 3, into 2 plus 3. Apply the same here. 4 to 8 plus 3. 8 plus 3, 11. Perfectly matching. So what is my logic is? Into 2 plus 3, into 2 plus 3, into 2 plus 3, into 2 plus 3. And also my suggestion, don't try to identify the logic in the smaller numbers. Try to identify the logic first in the larger numbers. Because the smaller numbers we can relate in so many ways. But the larger numbers we can relate in very less number of ways. So that's why my suggestion is identify the logic in the larger numbers, but not in the smaller numbers. So what is the confirmed logic? Into 2 plus 3, into 2 plus 3, into 2 plus 3, into 2 plus 3. So it is not following any classification. Constantly every time it is multiplying by 2 and added by 3. So now I apply the same logic. 109 into 2 plus 3. 109 2 is 218 plus 3 is 221. It is which option? Choice 4. Make a correction. It is not the D. Choice 4. So what is your answer? Choice 4. 221. And the logic is into 2 plus 3. Okay. Look at the 16th one. 5, 4, 9, 40, 273. Yes, definitely you can say that increasing rapidly. 40 to 70 there is a big jump. 9 and 40 also there is a big jump. And just now I suggested you not to identify the logic in the smaller numbers. Try to identify the logic in the larger numbers. 40, 273. Maximum it goes 7 times. 47 is a 280. What is the number given here? 273. So what I can say? Into 7 minus 7. Okay. 9 and 40. You can write like into 4 plus 4. 9 4 is 36 plus 4. Or you can write into 5 minus 5. Let's see which is the opt one. Let's see. We'll go ahead with the remaining numbers and we'll confirm it. Into 5 minus 5. 4 and 9. I can write like into 2 plus 1. 4 2 is 8 plus 1. Or 4 3 is 12 minus 3 9. Into 3 minus 3. Now tell me which is the opt one. Into 7 minus 1. Into 4 plus 4. Into 2 plus 1. Or into 3 minus 3. Into 5 minus 5. Into 7 minus 7. Which is opt one? Second one. Yes. So rule out this. 5 and 4. Look at here. 7 into 7 minus 7 into 5 minus 5 into 3 minus 3. 5 and 4 into 1 or minus 1. Look at here the numbers which I am multiplying. 1, 3, 5, 7. What is this 1, 3, 5, 7 classification? Consecutive odd numbers. So 1, 3, 5, 7. Next odd number will be 9. If it is 2, 3, 5, 7 prime numbers. Next prime number will be 11. But here it is odd number. Next to 7, 9 into 9. And the numbers which we are subtracting are minus 1, minus 3, minus 5, minus 7. So minus 1, minus 3, minus 5, minus 7. Next will be minus 9. So into 9 or minus 9. So 273 into 9 minus 9. Clear? So 273 into 9. 273 into 9. We can do in calculation two ways. One is do the 10 times and subtract the 1 time. 10 times is 2730. Subtract the 1 more time. How much you will get? 7. And here it is 5. And it is, how much it is? 4, 2. So 2, 4, 5, 7. And I need to do minus 9. So how much you will get? 2, 4, 4, 8. Do you have this number? 2, 4, 4, 8? No. So what is my answer? None of this. Choice 4. Choice 4. Clear? And the logic is multiplied with odd number, consecutive odd numbers, as well as subtracted with the consecutive odd numbers. Difference and product combination. Clear? So far we have discussed the 4 logics. One is consecutive series, one is difference series, one is product series, and the combination of product and difference. Now let's see the next logic. This logic comes under alternate series. You may be given these brackets or you may not be given these brackets. More number of numbers will be given in the series. More number of numbers will be given in the series. So that you can understand that the given series is alternate series. So you need to identify the logic in the alternate numbers. Okay. 55, 57, 59, missing and 63. What are these numbers? 55, 57, 59? Consecutive odd numbers. So after 59, what is the odd number will be? 61, which is a missing. Now look at here. 23, 29, 31. What are these numbers? 41. Consecutive prime numbers. So that's why I am suggesting you, please by heart those numbers. Prime numbers, squares, cubes. You should recognize quickly. Okay. 23, 29, 31 are consecutive prime numbers. After 31, prime number is 37. And after 37, prime number is 41. So perfectly matching. Perfectly matching. So what is the given logic is? First numbers is consecutive odd numbers. And the logic in the second numbers is consecutive prime numbers. If more number of numbers are given in the series, you can apply the alternate series. So 61 and 37. Choice 1 is our answer. So given series is alternate series. Choice 1. Achha. There are two options with 61, 37. I'm sorry. Or make a correction. Make it this 61, 35. Okay. 61, 35. And choice 4 is correct. 61, 37. Clear? Now, 18th one. Look at here again. 1, 8, 9, 64, 25, 216. Can you recognize these numbers? What is 25? 5 square. What is 216? 6 cube. What is 64? 8 square or 4 cube. 9? 3 square. 8? 2 cube. 1 square or 1 cube. Now let us look at the pattern and tell me which can be correct. If I go with the squares, it is not a square. If I want to go with the cubes, 9 is not any perfect cube. Okay, but see here, cube here and here is a square. But still here I can go with the cube and again I can go with the square here. Again I can go ahead with the cube here and I can go with the square here. So 1 square, 2 cube, 3 square, 4 cube, 5 square, 6 cube. So alternately square logic and alternately cube logic is applied. And what are those numbers? 1, 2, 3, 4, 5, 6 are consecutive natural numbers. So next will be 7. But which logic to be applied? Square, cube, square, cube, square, cube. Next will be square, 7 square. 7 square will be how much? 49. So alternately square logic and alternately cube logic. Clear? So 49 is our answer. Choice 3. Alternately squares and alternately cubes. Now see the next question. 11, 12, 23, 35, 58. 11, 12, 23, 35, 58. So this type of questions comes under digit logic. This type of questions comes under digit logic. The digits given in the series themselves follows a specific pattern. The digits in the series itself follows a specific pattern, like Pythagoras triplets, Fibonacci series, this kind of logics. Look at here. 11 plus 12 is equal to how much? 23. 23 plus 12 is how much? 35. 23 plus 35 is equal to 58. So sum of the previous two numbers is equal to the third number in the series. 11 plus 12, 23. 12 plus 23, 35. 23 plus 35, 58. So what will be my next answer? 35 plus 58. So 35 plus 58 is how much? 93. So what is my required answer? 93. Pythagoras triplets, Fibonacci series, all these type of questions comes under the digit logic questions. Okay. Here sum of the previous two numbers is equal to the next number. So digit logic questions. And whatever the logics and the rules that we are discussing, these are not the exhaustive list. While going to the study material, you will get so many different kinds of logics. Okay. So choice 2 is our answer. Clear? Now move to the next question. Now look at here. It is a one different kind of question. 23, 35, 57, 711, 1113. Okay. So instead of reading like this, let us split the numbers and read it. 2, 3, 3, 5, 5, 7, 7, 11, 11, 13. What are these numbers? Prime numbers here. 2, next prime number 3, next prime number 5, next prime number 7, 11 and 13. So consecutive prime numbers are taken. So set of two numbers are taken together. Set of two prime numbers are taken together. 2, 3, 3, 5, 3, 5, 5, 7, 5, 7, 7, 11, 7, 11, 11, 13. Next will be 13, 17. So set of two prime numbers are taken together. 13 is a prime number, 17 is a prime number, but are taken together in the series. 2, 3, 3, 5, 5, 7, 7, 11, 11, 13, 13, 17. Okay. Not only this, there is one more example you may expect in this way. That is 1, 4, 9, 16, 25, 36. Dash. It is also same. Split it. 1, 4, 9, 16, 25, 36. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. So set of two squares are taken together. So next will be 7 square, 8 square. So 49, 64. So this is my required answer. So this type of questions are also expected. Okay. So consecutive prime numbers are taken together. Set of two prime numbers are taken together. 2, 3, 3, 5, 5, 7, 7, 11, 11, 13. And the next is 13, 17. Okay. So with this, we have done with the digit logic. So we discussed the 6 rules, that is consecutive series, numbers themselves follows a specific pattern. Different series, numbers are close to each other. Product logic, one number is a multiple of other number. Difference and product logic, increasing rapidly but not an exact multiple, then difference and product logic. Alternate series, more number of numbers will be given. Digit logic, numbers themselves follows from some pattern. Clear? Okay, so that's it for today. Please keep practicing the questions. If you get any doubt, get back to us. Thank you for joining the session. Thank you for joining the session. Have a nice day.